Okay, I want to practice converting decimal form for some unusual fractions and look at some techniques and how we might go about getting that point across. I want to point out that this is designed to be a non-calculator skill. So it's really easy when you can hit buttons in the calculator and generate an answer, right? But that's not the goal here. The goal is to show you how to do it and have you eventually show students how to do it without a calculator. Okay, so what I'm going to do, by the way, there's our fraction. 7 over 2 to the 6th power, let's see, 2 to the 6th is 64. So this is 7 over 64. And we're going to try to convert this into some form of 10. Okay, so what I'm going to do is I'm going to multiply by 5 to the 6th. And you're probably thinking, why would he do that? Well, hold on, let me show you. Our fraction rule says if I am raising these to, exponent rules says if I have two numbers to the same power, that I can essentially bring out the power. Now, normally we see it in reverse. Normally it's 2 times 5 raised to the 6th, and we're going to bring the exponent in, but we're going to go backwards on this time. And notice what we get in the denominator, right? We get 10 to the 6th. Okay, so all I need to know is what is 5 to the 6th power. And I know I talked about this being a non-calculator component, but well, let's look at the denominator for a second. 10 to the 6th is 10 with 6 zeros at the end. So 1, 2, 3, 4, 5, 6. So we're looking at something like that. And I now just got to do the hard part of what is 5 to the 6th power, right? Well, we get 5 cubed times 5 cubed is 5 to the 6th, and 5 cubed, hopefully we know that, is 125 times 125. Okay, so I want to do 125 times 125. I'm going to do a little bit of an expanded technique here. I'm going to say that's 100 plus 20 plus 5. And that hopefully can be a little bit easier to do in our heads, maybe. So 125,000, sorry, 2 zeros, not 3 for that one. 125 times 20 is, well, 125 times 2 is 250. So we got 2,500. And then 125 times 5, would be 625. And then I just want to add those three numbers up, which is, let's see, 15,625. Okay, so our numerator now is 7 times 15,625, and then I just want to multiply that by 7. And hopefully, let's see, so 35, carry the 3, 14 plus 3, 17, carry the 1, 42 plus 1 is 43, carry the 4. Let's see, 5 times 7 is 35, carry the 4, plus 4 is 39, and then that. So what is that, 109,375? Okay. So let me kind of go back down here. All right, so we have 109,375 over that very large looking denominator. I think I have the right number of zeros. Okay. Anyways, so our decimal is 0.109 375. Sorry, I just caught this, so I wanted to make sure that I acknowledge this before I get the emails of confusion. I have 6 zeros up here, and I only put 5 because I just wasn't paying attention. So there really are 6 zeros. Anyways, so that's where that came from. Okay, let's do another conversion of a fraction to decimal. So 1 over 2 cubed times 5 to the 4th. Okay, I'm going to try to figure out a way to get that to be some power of 10. And it'd be really great if that 2 cubed is actually 2 to the 4th. So I'm going to multiply 2 to the 1st times 2 to the 1st, which gives me 2 in the numerator. It gives me 2 to the 4th times 5 to the 4th in the denominator. So then I have 2 over, and then I'm going to separate out that exponent. So 2 times 5 to the 4th down below. So that's 2 over 10 to the 4th, right? So in expanded fraction form, that's 0 over 10 plus 0 over 10 squared plus 0 over 10 cubed plus 2 over 10 to the 4th. So our decimal is 0.0002. Nice, clever way around that. Okay, let's do another one. 1 over 125. Okay, so we got to think, what is 125? That is 5 cubed. So I'm going to multiply it by something that'll give me a power of 10, and that would be 2 cubed. So I'm going to have a 2 times 5 cubed that I'm going to eventually pull out of this. Let's see, up top we get an 8. Down below we get 5 times 2 raised to the 3rd power. So that's 8 over 10 cubed. Okay, so that's 0 over 10 plus 0 over 10 squared plus 0 over 10, 8 over, I don't keep doing that, 8 over 10 cubed. Okay, so as a decimal, that translates into 0.0008. All right, let's look at one more example. Let's do 7 over 250. Okay, so I need to first figure out how can I break up 250. Well, 250 is 2 times 125, and that's 7 times 2 times 125 is 5 cubed. Okay, so if I had 2 cubed and 5 cubed, I could have my 10 cubed. So I just need to multiply by whatever is going to make that 2, say 2 cubed. So I'm going to multiply by 2 squared. All right, so I have 7 times 4 up top, and I have 2 cubed times 5 cubed. So I have a 28 on top, and then I can pull out the exponent, so 2 times 5 cubed. So 28 over 10 cubed. Okay, so let's do our expanded form here. Let's see, so actually before I do that, let's think about how many factors of 10 I can pull out. So 28 is really 2 times 10 plus 8 over 10 cubed, right? So I can split that up into 2 times 10 over 10 cubed plus 8 divided by 10 cubed. And so that translates into 2 over 10 squared plus 8 over 10 cubed. So let me fill in the other positions that are missing so we can kind of see what where the 0 goes in the place value. So that's 0 over 10 plus 2 over 10 squared plus 8 over 10 cubed. So we can see that it's 0.028. Yay! Okay, decimals that can be written with only a finite number of places to the right of the decimal point are called terminating decimals. Okay, terminating decimals sort of brings up the idea that not every fraction can be written as a set of terminating decimals. Okay, so let me give you two illustrations of something that terminates versus something that doesn't. 23 over 100 versus 2 over 11. Okay, so 23 over 100. Okay, so 23 over 100, using the techniques we've just been looking at, I would break the 23 up into 2 times 10 plus 3, and then 100 is 10 squared. And then I want to split that up into two fractions. So 2 times 10 over 10 squared plus 3 over 10 squared. The 2 times 10 over 10 squared simplifies down to 2 over 10 plus 3 over 10 squared. And so we can see, using place value, that it is 0.23. Okay, what about 2 over 11? Can we come up with a terminating? So just back up here. What makes this terminating is eventually I stopped. I had no more numbers after a given value. So it terminated or stopped at a certain point. What about 2 over 11? Is it possible that I could write that in that form? Well, I would be looking for some expression that I could multiply 11 by to get it to say 10. Okay, so let's talk about 2/11ths then. How would we go about coming up with a decimal equivalency to this? Well, we're looking at powers of 10 in that denominator. So that means there's got to be some number out there that I can multiply 11 by to get it to convert to some power of 10. And if you think back to our factors, there's nothing. There's no way I could write 11 times some number. I mean 11. So I could multiply by 10 to get 110, but again, it's not. I can't rewrite it as 10 to some power. Is where the problem is lying. If I can get it to say 10 to some power, then I can come up with some terminating decimal. Okay, so because I can't do that, then 2 over 11 has to be something else, which we would call a non-terminating decimal. So let's kind of practice looking at some fractions and identifying whether they're terminating or not.